Okay, good. Yeah, so in this session named, was it semantics and AI or something? There's no AI. Methods for AI, there's no AI. Okay, so sorry. Yeah, this is work done by PhD student Mariam Mohammadi. Her interest is in generating metadata for knowledge graphs. And so together we thought about how can we get a description of a knowledge graph without necessarily looking at the knowledge graph. And the idea here is to look at what people ask about the knowledge graph and see to what extent it covers the content of the knowledge graph. Okay. Yeah, so we are seeing lots of presentations about knowledge graphs, largely RDF knowledge graphs, but also Cypher, Neo4j type knowledge graphs. These are very good for data integration and for knowledge exploration, and of course for semantic query answering. People ask specific questions when they come to it. It's not just searches with keywords, but it's typically quite precise in terms of what they want back. So yeah, RDF graphs can be queried with SPARQL, the query language for RDF graphs. It has a number of components to it in terms of the variables that they want to return, the query pattern, this part of the graph they are interested in, and some other solution modifiers. Yeah, SPARQL query looks something like this, which would be asking about on a database called biotrf, which is one that we built, asks about the relationship between enzymes and drugs that interact with them. Yeah? It takes some degree of expertise to compose this query. You have to understand the schema, and you have to understand what you're looking for, and you put it together. Yeah, so databases that receive these SPARQL queries log them for the most part. You can look at the privacy policy and figure out what they're going to do with them. But there have been some efforts to collect, aggregate these logs, and to use them for research. So we can understand what do people ask for, and perhaps this can inform database optimization. That is, what parts of the knowledge graph should we index to make available for repeated queries? And what are the kinds of things that really make the performance of the graph or the engine very poor? And how do we improve that? So a big part of research on analyzing SPARQL logs is for database optimization. There is some work that looks at what are people doing? Like, what are they asking? And how are they asking the questions? This is really the syntax and semantic features of SPARQL queries. And they look at the language, they do language profiling, they look at how people might be building up queries iteratively over time, and what, of course, is the content. What are they asking about? But one resource is this LSQ, linked SPARQL queries. So here there is a number of collected SPARQL logs, including those from biotrf and many others like Wikidata and DBpedia and others. And this tells you the anatomy of SPARQL queries by users. What are the syntactic components of SPARQL queries? What is the complexity of these queries that they're asking? And this is pretty much what they're looking at, right? And runtime statistics and things like that. Others have been analyzing to look at how people build up queries. So how are they progressively getting more complicated queries that could be seen from the query logs? And there is also some work that tries to distinguish those queries that are formulated by humans and those by machines. And they have distinct signatures and they have different compositional components. But actually, there is not very much about what are they looking at, what are they asking about? So for instance, are they asking about drugs and diseases, or what kinds of relations between those? So the actual content, there are not so many studies. And this is a bit what we wanted to do here. We want to know what parts of a knowledge graph are being queried by agents, and to what extent does this cover the schema of the knowledge graph? When we first started this, I thought probably a very small portion of the biotrf knowledge graph is actually being asked by users. I would say something like 25%. Because there are many data elements, we just transform the data, and nobody is going to ask about these things. So my hypothesis was 25, 30% of the schema. I'm curious, what would you think? So how many people think it's between 0 and 25%, 25 to 50, 50 to 75, and 75 to 100. So let's put first category, 0 to 25% of the schema will be covered by the SPARQL queries. Yeah, that is a reasonable guess. That was my guess also. What about 25 to 50? Okay, a few more hands there. All right, it's actually kind of split. Then 50 to 75. Yes, okay, 1, 2. And then 75 to 100. 2. Let us see who is correct. Yeah, so here's the idea. We have some knowledge graph, a schema, which are effectively the types and the relations between the instances of those types. This gives you the subway map. What are the categories of things and what relations hold between the instances of those categories? So it's illustrated like in a picture like this. And then here's an example of a set of SPARQL queries from the SPARQL log. We are interested in the parts that are specifically named. That is, you see something like this, refers to a category in the knowledge graph, or a relation over here, or a specific literal. So we're looking for specific things that they're asking about, not generally, but really specific mentions. All right, so what do? First, we extract the schema from the RDF graph. Then we extract these constants from the SPARQL logs, and then we compute the number at the end. Okay, we use BioTree-F version 3. This is the one that is currently online. And there are 3.8 million queries that we have in a period of 2 years. And we have Python notebooks here if you want to verify the work. Okay, so first we extract the schema. We do this simply by issuing SPARQL queries. We ask for all the graphs in the endpoint, and then for each graph, we ask for all the types, and then we also ask for all the predicates. Okay. Yes, we do some processing of the SPARQL queries. There's a whole bunch of stuff here. I probably don't have really the time to go through it, so I will quickly go through it. But effectively, we are cleaning up the files. We are adding prefixes because these are assumed by some of the users and allowed by the SPARQL endpoint, which says you don't need to name the RDF prefix. We know what you're talking about. But the parsers that we use, like SPARQL.js library to say, is this a valid query, need to know what the prefix is. So we inject those into the queries so that we can parse them correctly. And then we normalize the queries, we deduplicate them. So people ask the same questions over and over again, but with different variable names, okay, and in different orders. So we account for that, and we replace the variable names they use, and we normalize them with some ordinal assignment here. So these 3 queries are become the same query. We ignore the solution modifiers like limits and offsets and things like that, okay? Yeah, we parse these queries and we find those that are syntactically valid. So you remember these are public URL points. People put all kinds of stuff that have nothing to do. There's Viagra posts and all kinds of things. They're not all SPARQL queries. There are all kinds of things you can put on an HTTP server. We find the actual SPARQL queries that actually parse. Yeah. Yes, then we look at the triple patterns portion and we identify the URIs that are specifically mentioned. And yes, then we also ask for each of the entities, what kind of thing they are. If it's a literal, what kind of thing mentions that literal. And then we check whether there's actually a predicate in the database there. Then we compare the things we see in the SPARQL logs versus the knowledge graph. Okay. So here's what we see in BioTree-F. In BioTree-F, we have 26 graphs, 532 distinct classes, and 1,100 predicates. Okay, that is a very large knowledge graph, lots of different things in it. Let's see now. We do our processing of the SPARQL logs. We get a total of 633,000 unique queries. We standardize that to 545,000. This covers 2 million triples. We get 30,000 unique entities and 506 entity types, 1,100 unique predicates. Okay, this is the comparison. You can see we get actually an enormous amount of coverage. So for the 2 people that said that was you and that was German, basically it's in the 99% or 98% range. This was extremely surprising to me. However, we have to qualify it a little bit because what we don't know is kind of the frequency of these. And there are many bots, of course, that can run across these. And we need to now look and kind of do a thresholding across this and figure out which are the substantively asked entities and relations in there. Okay, so this was kind of a preliminary study where we start to look at which parts are being queried and to what degree this covers the graph that is actually there by looking at both the in-use graph and the actual SPARQL queries that people are asking about. Yes, so we want to look now more seriously about what portions are really the hot spots, what are people mostly interested about, because if I try to give you metadata about a graph and I give you 98% of all the data elements that are there, it is not very effective. So we have to triage this a little bit. And we need to look at, does this change with time? Is it only during the period of COVID that people were asking so many things, or we have logs from before that? And do these generalize with other graphs like Wikidata and things like that? So that is the main idea. Yeah, thank you for your attention.
This presentation, it's fantastic. And I was just going to say, you should look at the difference between the queries in the weekend and during the week. Because I've done a similar analysis on sparkle.infra.org, and bots work in the weekend and people go on holidays.
Yes.
That really separates out these two categories really cleanly if you have enough users.
Yes,
so,
yes.
Love it.
That's very good. And as I already mentioned, the other work that already can better identify organic queries from user queries. So I think that would be a next part of our work, is to focus on the user queries rather than the agent-generated queries. Yeah. Thanks for that hint. Yeah.
Other questions?
So I'm wondering, when you see the patterns of the bots, are they systematically somehow crawling through the whole the whole store, or how are they operating? Can you see some patterns?
We have not yet done this work.
Yeah. Okay.
Yeah. I hypothesize that some of this is bot generated, as has been shown in other work. But in this work, we have not separated these. And as Jurven has indicated, there may be some heuristic we can apply, or perhaps there's some machine learning we can do, and we will separate human-generated queries from system-generated or bot-generated. I don't know what they look like.
Yeah. I'm very curious. But did you see, like, can you derive some recommendations for the construction of such databases that you, in the end, get a recommendation for an optimum shape of a database? Will you be able to do such thing?
Yeah, this is a bit in the database optimization part, and there's two parts to that. One is database optimization for the purpose of indexing and retrieval, but the other is for people who build knowledge graphs. Right? I mean, if you can figure out that people are super interested in drugs, let's say, and maybe their indications, but they're really not interested and not asking about some of the other properties, maybe that will adjust your curation. And maybe that has been done in other organizations that have far more resources than me. But this would be an important business intelligence. If you're in the business of curating data, you better know what people want to see. Right? That is your business, right? So this could be an insight, yeah.
Thank you.
Other questions?
Like Jervin, I really like this presentation. And I have a question/comment. We did a similar study in 2018 with Wikidata. And then what came out of that is that the pairings, so if you look at the predicates of the logs, you get actually a measurement of the reuse. So we would see someone write a SPARQL query, and then they would combine SNOMED and OBO and Mondo, etc. And then you had some sort of measurement. But then at the time we were closed down for that exercise because the log files contain privacy information.
Oh, yeah.
So I was actually trying to have you run into that. The argument then was, especially in Europe, if you parse the log files, you're basically touching on privacy spaces. So I'm really curious to see if you run into that, or if you find a loophole. Because the thing, when we're working in Wikidata, we're trying to put the data in there. But the problem at the time was you cannot convince researchers to put their data into knowledge graphs because there is no metric to show what the return of investment is. And we had this assumption, we had this first indication that using those lag files can actually show you that if people start querying for those combined predicates, that gives you some indication of that by putting it in there, those data sources are interoperable with each other, etc. Yeah. So I'm curious if you ran into the same privacy issue with the log files, and if not, please let's talk.
Yeah, I think you raise an important point, and indeed, logs are deemed personal identifiable information. In our case, we removed any of the information regarding who is asking the question, right? The IP address and the agent and things like that. So we are just focused specifically on the queries. And then the queries, the graph, the target graph is not personal data. It is public biomedical data. So there is no personal identifiable information in what we are processing.
So I had the same reasoning, and then I was told that actually they do. I never understood why. They actually say when you start querying for combinations, like you said,
there's no identifiable information here. I'm happy to have a discussion with any lawyer.
I hope we don't have lawyers in the room now.
But certainly, if you are working with logs that pertain to data that are personal data, this is something going to be a big concern for you, and you're going to need consent for that.